I am Joan Amara, and today I'm virtually shooting a video that was requested via my DM. Someone contacted me for this video. So I know it's out of line of what I've been posting, but let's get into this, okay? We're going to learn how to sketch first order ODE that are autonomous, okay? That are autonomous. So what does it mean for um, a first order differential equation to be autonomous? So the first order differential equation is autonomous if and only if the independent variable, usually we have the y by the x, so the independent variable is simply say x, okay, all right, does not appear explicitly. So if we cannot find the independent variable, if we cannot find the independent variable in an equation, then we say that that ODE is autonomous, okay. If we can't find that independent variable in that equation, then we say that the equation is autonomous. Okay, before we go deeper into this, we need to know something, because to sketch differential equations, this is very important. So what is it? Critical points. And so how do we find critical points? So we are actually considering autonomous equation. So consider the y by the x is equals to f of y. If you notice, you can't see any x here, okay. This is just the dependent variable standing alone. We are not seeing any independent variable here. Let's call this equation 1. The critical points are simply found by saying where f of y is equal to 0. The critical points are found when you have f of y is equal to 0. So you get the values of y, okay, to get the critical points. So what are your y's? That's how you get your critical point. So if you equate the expression at this side, you get your f of y and equate it to 0, you get your points that are critical, your y, okay. Yeah, I would like you to know at this point that critical points are also called equilibrium points. We'll see that as we go on, okay. So let's move to facts that we need to know before we can even sketch any autonomous differential equation. This will help you at every point, and I'm going to be buttressing on this fact, okay. Fact 1: any autonomous equation is either strictly increasing or strictly decreasing. So you check your dy by dx, the f of y at the other side, check it at some point, why not. If it is bigger than 0, then we say that it's increasing. If it is less than 0, then we say that it is strictly decreasing. And this is very important because autonomous curves either go upwards or downwards. They're usually slopes. You will see that as we move on. Fact 2: so if we can solve the differential equation and we get our y in the interval 0 comma t max, that it has a maximum value, y is in this interval, okay. So that t max is less than plus infinity, that means t max does not keep, like, t max is not infinity, like it's a real number, it's in r, okay. It's finite, so that t max is finite. It's a number, you can call the number. Then we have that limit as t goes to t max of y of t is equal to plus infinity. So what this thing is saying is that as t is going to t max, the graph will be going upward as if it's going to infinity. It will keep going upwards. Okay, it will keep, if you have your T max to be here, it's going to keep going. Sorry, if you have your T max to be here, it's going to keep going up as if it's going towards infinity. Okay, so as T goes to T max, it keeps going upward, like the slope keeps going straight up. That's what it's trying to say. So the limit as T goes to T max is plus infinity. Fact 3. Fact 3 is saying that the solution of autonomous differential equations do not touch each other. This is very important. So if you have that, okay, let me just write that quickly. Do not, this is very, very, very important. For no reason should they touch each other. So even if you have 1,000,000 solutions, they will never have a point of intersection. So they do not touch each other. So so if you have y naught, the solution y naught, and you have another solution y1, when you graph these 2 points, they will never ever touch each other. There is no point in which any of the two given y naught or y1 will touch each other, the sketch of any of these two. Okay, all right, now finally once you know these 4 facts, sketching can never be a problem. Okay, what I always say, as a good mathematician, you must always be obedient. Sometimes you may feel, is it really right? Just obey. Forget about whether it's right or wrong. They say this principle goes this way, it doesn't do this, it does this. Obey instructions and you will be right, you'll be on the right track. Okay, fact 4, and this is our last fact. If the limit of yt exists as t goes to infinity and is equal to y prime, so if I have limits, before we said that t max is not infinity, that means it's strictly less than plus infinity, is a finite number. But now they say if t is going to plus infinity of yt and that this is equals to y star, okay, that this y star is called what? An equilibrium point. Another thing you can say is what? It is also called a critical point. I told you before that critical points are what? Equilibrium point. And anytime you are sketching any type of autonomous equation, any equation, you must first note your critical points, that's your equilibrium points. Okay, let's take some exercises. For me, taking examples and exercises is the fun part of everything. Okay, so let's start. We have the y by the x is equals to y a minus b y. Now take a look at this equation. The first question you like to ask yourself is this autonomous? Yes, that was dramatic, but yes, sincerely, that's the first question. And how do you answer it? Check. Where is my independent variable? This is it. Can I see it on this side? No. So what does that mean? It means that the equation is what? Autonomous. I'll just write it as auto, okay? Now I can move forward. The next step is what? Get your critical point. So you need to find out where f of y is equals to 0. Critical point. Alright? Where f of y is equals to 0. What's your f of y? Your f of y is what? Y times a minus by is equal to 0. So what does this mean? Y is equal to 0 and this is equal to 0. So this means that what? Y is equal to 0 and a minus by is equal to 0. So this implies that if a is equal to by, and this implies that what? Y is equal to a over b. So what is our next step? We need to sketch. So what I like to do is draw a rough sketch. I have 2 equilibrium points, this and this. Oh, I didn't give you the complete question, sorry. This says that y at 0 is equal to y naught, okay, and that a comma b are bigger than 0. I'm so sorry about that. Let's just move quickly because we need to know that our a and b are bigger than 0. If it's not bigger than 0, if one of them is less than 0, then it can be negative, right? And if both of them are less than 0, then it can be positive. Y can be positive. And then if, yeah, so we have two contrasting points. That was why it's very important that this condition was given. Okay, I'm so sorry I left that out. Okay, let's move. What next do we do? Draw a rough sketch. So let's quickly sketch that. You must take note of your critical points first. Okay, so consider that part as y. So let's assume that this is y is equal to 0, as this is 0. Okay, this is the origin. So what we have here is y is equal to 0. Now we know that another critical point is what? Y is equal to a over b, and a and b are bigger than 0, so that means this is bigger than 0, so it will be above 0. So let's just take arbitrarily that this is a over b. So I can just draw my y is equal to a over b. Forgive me that my lines are not so straight. It is well. All right, that's supposed to be a straight line in my mind. So now, our possible solutions, they said y of 0 is equal to y naught. There are three possible places I can find this. I can find this y naught here, y naught can be here, y naught can be here, and then y naught can be here. So I will call this region 1, call this region 2, and then I'll call this region 3. The next thing is to consider the three cases. So case 1 is in region 1. Okay, so in case 1, what do we have? We have that what y naught is bigger than a over b. Y naught is bigger than a over b. So what does y naught bigger than a over b means? You know that this is bigger than 0. It means that what by naught is bigger than a. I just multiplied through by b. Okay, and this means that what by naught minus a is bigger than 0. I really like to take things step by step. So what does this mean? It means that what a minus by naught, the sign will change. If you notice, I multiply through by minus. Okay, we'll have what less than 0. Okay, so we know that y naught is bigger than 0 and y naught is bigger than a over b. So let's move. We were given the y by dx is equal to y a minus b y. Okay, so given this equation, we are trying to see what happens at y of 0 is equal to y naught. So let me just say at y of 0. Okay, we have what do we have? We have everywhere we have y, it becomes y naught. Okay, but what does this mean? We said y naught is bigger than 0. This is bigger than 0, but this is less than 0. So if you multiply a number that is less than 0, like minus something, with a number that is greater than 0, that's just plus something, a number, you're always going to get a number that is minus something. Okay, so whatever your answer will be what? Less than 0. So what does this imply? I told you that if it is less than 0, then the curve at that point is what? Strictly decreasing. So y is going down, baby. So it's strictly decreasing. Strictly decreasing. Alright, that's case 1. This is not going to be my final curve. Okay, this is like a rough sketch. I know that it's decreasing, so it's something like this, but it must pass through y naught and then go down. It's not so clear, but it's going down and it's not touch y. Sorry, make sure that when you're sketching, you don't touch your y is equals to a over b. Don't do it. Okay, because why? Because the no, why not, no curve would touch each other. There's no point of intersection, no curve meets at any point. Okay, just know this, keep it in your heart. No curve meets each other, no two curves meet each other. So let's go back and do case 2. We can see that y naught is in between 0 and a over b. Y naught is in between a over b and 0. So what does this mean? It means that first of all, y naught is bigger than 0, right? And then what does this mean? It means that b y naught is less than a. I'm considering this part, okay? I multiply through by b. And then what does this mean? This implies that b y naught minus a is less than 0. But I have my equation of the form a minus by naught. So I just multiply through by minus 1, and I have what? A minus by naught is what? Bigger than 0. So just for a quick peep into the future, I'm teaching you foresight now. Look at y naught, multiply it with this. Two positive numbers multiplying themselves is what? Positive, bigger than 0. So I have seen that the curve passing through y naught at this case too is going to be what? Increasing. So let's see it. Dy by 0 by dx is equals to y naught a minus b y naught. This was the original equation, just that I'm taking at a specific point. And this is what? Bigger than 0, because this is bigger than 0 and this is bigger than 0. Okay, what can we see? We can see that y is what? Increasing. Strictly increasing. Good. So we can go back to that our rough sketch and show what it means to be strictly increasing. When I say increasing, you move from your negative axis and climb up. Okay, decreasing still from the negative axis and go down. We are back here. We are trying to say what? It is strictly increasing at this point. So I am moving from this negative axis, passing through y and increasing, but I'm not touching y is equals to a over b. Now the last region, we are almost done sketching. So I have y is less than 0. You can see that this is below 0. Okay, case 3 is in R3. Y naught is less than 0. So what does this mean to you? It means that what? Dy by dx, right, is equals to y naught, at 0, is equals to y naught times a minus b y naught. Okay, this is less than 0 and this is positive. So this means that this whole thing is positive, because minus b times a negative number will be bigger than 0. So I'm adding a to a positive number. So this whole place is bigger than 0. That's what it means. Okay, but what does this place mean? Is less than 0. So I'm multiplying a negative number by a positive number. So it's what? Less than 0. Less than 0. What do we do now? We know that what? Y is decreasing, because this is less than 0. Once you see that it's falling down from 0, that's reducing, going down, this is what? Strictly decreasing. So what next? We go back to the graph and sketch a strictly decreasing curve at y naught there. As easy as that. So we can just quietly go now and we graph this if you are not comfortable with your rough sketch, which I am not. This looks terrible. So let's regraph this. So this is my first critical point, y is equal to 0. So my next critical point is at y is equal to a over b. So let's take this position. I hope it's better. So y is equal to a over b. In the top section, we know that it's decreasing. So I can pick any point here. I can pick here as my y naught. And then show that it is decreasing. Okay. So it's decreasing. Now the next one is increasing. So I can pick y naught at any, you can pick y naught at any point. You can choose it to even be up here, very close to your stuff. So you just, yeah, you are increasing. Y naught is increasing, okay? Never touching a over b. Remember, never touching a over b. And then this one is what? Decreasing. It's usually better to draw before picking any point that you pass through as your y naught. So yeah, true. So this graph, the y by dx is equals to y times a minus b y, where what? We have a is bigger than 0 and b is bigger than 0. So we are through with the sketch. I think I should take one more example. Should I? I think it will help. Let's take one more example. We'll sketch sine something. It's a trigonometric graph, okay? So sketch dy by dx is equals to sine y. Now if this question was what? Sine xy, would this be autonomous? No, because this is the independent variable and it's showing at this other side. So make sure that your independent variable is not showing at this other side before you can use the theory of autonomous to sketch. Okay, for now this is not an autonomous graph. Okay, but I want us to work with autonomous graph, so let me correct that. So we have sine y, where y of 0 is equal to y naught. Okay, so let's sketch this. For simplicity, because we have many critical points, as sine y is equal to 0 at various points, plenty points. So we are going to take what, restrict ourselves to n is equal to 1. Let's not bore you with the whole, you see this, the whole pattern. You keep doing it, okay? All right, so let's solve. So solving solution. What do we do next? Find where f of y is equal to 0. So this implies that what? Sine y is equal to 0. And when is sine y equals to 0? When y is equals to plus or minus n pi. What does this mean? Sine 0 is 0, okay? Sine pi is 0. Sine minus pi is 0. Sine 2 pi is 0. If you keep going and keep going, you have many points. So we just call this n, okay? If you are not still clear about this, let me show you. How does your sine graph look? Your sine graph is saying that when you have 0, you have sine 0 is 0. So it's something like this. Okay? It's something like this. If you notice, this is 0, this is pi, that's 180 degrees, this is 2 pi, this is minus pi. You come back to 0 at every 180 degrees. So it's just the same thing as saying that y is equals to minus 2 pi minus pi 0 pi 2 pi up to, we don't know, plenty, there are many. So we just contracted it to say that what y is equals to plus or minus, because you see this is repeating, this is with this is with this times alone, plus or minus what, n pi, where n is equal to 0 comma 1 comma up to infinity. N is equal to 0 or 1. So we have this critical point. Now let's sketch what the autonomous graph will look like. First of all, you identify your critical points on the graph. Identify your critical points on the graph. Very important. We take this to be 0. Okay. So y is equal to plus or minus n pi, where n is 0 or 1, means that y is equal to 0, y is equal to pi, and then y is equal to minus pi. I just felt you should know this. Just plug in 0 and 1, you get those 3 points. So we have that this is y is equal to 0. So the next thing is to locate y is equal to pi. So I take here, that's my y is equal to pi. And I take down here to be y is equal to minus pi. Please forgive my lines, they are not so beautiful, but manage them. Okay, so we have various regions. I won't consider this region because in this region we still have critical points like 2 pi, 3 pi, 4 pi, 5 pi. I'm not going to consider this because I won't get accurate results. So I'm going to consider this as region 1 and region 2. And I will also not consider this because down here I have y is equal to minus 2 pi, minus 3 pi, minus 4 pi, and sincerely you don't want to sketch something there and forget that you have a critical point stopping it. It won't make sense. Whatever you're sketching is as if it's going to infinity, and that will be wrong. Okay, so just have that in mind. So let's find out how would the graph look passing through a y naught in r1, and then passing through the curve look passing through a point y naught in r2. So let's go forward and see. So r1 is saying that what y is between 0 and pi. So let's go on. So case 1, y is between 0 and pi. This is quite tricky, so watch closely. Our function dy by dx, why not, sorry, it's in between this. So dy by dx is equals to sine y naught. So how can we predict how this y naught is moving? There are two ways. We can choose to use this graph. If we use this graph, it means that we must follow it this way. Okay, it's always like this. So you see that between 0 and pi is increasing. Okay, it's increasing, but let's see. A C T S. So we know that is what sign is positive here and here, negative here and here. So let's see that positive here, negative here, negative here. What is this? This is 0. This is pi over 2. This is pi. And then this is 3 over 2 pi. If you come back here, this is 2 pi. I don't think we'll be needing this. Now, if you look at this, the opposite of this is actually minus pi, okay? Just know that. And then what other one do we have? Yeah, that's all. So we are going to be moving. You know that when we move, we always move in what? Anti-clockwise direction. Opposite your clock. We move like this. Just know that. So if I move from 0 to pi, what does it mean? I'm moving from here clockwise to here. Every place I pass is positive, so it's what? Bigger than 0. Do you understand? Every place I pass there is positive. You can also see it on the graph. Let's go. Every place I pass here is bigger than zero. Here, this region is bigger than zero. This is less than zero. Okay, so you can obviously see that the other region is less than zero. But we have that this is bigger than zero and y is what? Strictly increasing. And we can go back to that graph and sketch what it means for y naught to be strictly increasing. It means that if I move from the negative side, I will be going higher and higher. I will not touch either of the critical points. Please note that they never meet. So yes, so if I were having other y naughts here, I would have something like this. Remember, it's not going to touch, so they keep going towards that side. Okay, but I just need one y naught, so let me just call this y naught. Okay, then the next one, this region, right? We've seen that it falls. We could choose to show you again, but let me just draw it falling. The use of foresight is very important. The region is between 0 and minus pi. You see that here it will be difficult to determine it. That's why sketching the curve was very important. We could use this curve to see that it's what? Less than 0. All my values are under the 0. So we are done. Graph simply looks like this. I could redraw it or leave it like this. This one looks actually finer than the first one, so I choose to leave it like this. Welcome to the end of the video. Yes. I'm so happy that you watched it to the end. If you watched it to the end, I really appreciate. Thank you. Please subscribe, like the video, very important. Like the video, give it a thumbs up, subscribe, and hit the notification bell so you get notified each time I post a new video. Very important, so you get notified each time I post a new video. Thank you.